I'm really, really pleased to introduce someone who's become famous in software for helping other coders. My job at UCL and Turing is to try and help scientists make code that's usable by somebody other than the PhD student who wrote it. That's quite interesting. So it's great to introduce John Skeet, who, as a lot of you will know, is extremely famous for being helpful on Stack Overflow. So what proportion of your working days do you end up looking at something on Stack Overflow? Every day? Put your hand up if you look at Stack Overflow every day. Right, there you are, you see? So, and the other ones would be like every 3 days or something. So, this is a thing that we're all very grateful for. I was looking up some things about John earlier. Apparently, to be skeeted is what does it say? The act of attempting to answer a Stack Overflow question only to find out that John Skeet has already answered it definitively and better than you could ever have done. Probably I should just have read out John's biography of himself now rather than making my own one up. But anyway, yeah, when they ask you to introduce John Skeet, the answer, of course, as people will know, the joke is, you don't introduce John Skeet. John Skeet comes into the room and the room introduces him. So apparently, a few more, forgive me, John. John Skeet's code doesn't follow a coding convention. It is a coding convention. John Skeet is the only top 100 Stack Over developer who is human. The others are bots that he coded to pass the time between questions. John does not use exceptions when programming. He has not been able to identify any of his code that is not exceptional. There's a few more of these. Since this is a Turing lecture, I'll skip through to number 20. John Skeet is beyond Turing complete. He's Turing invincible. Now, of course, John will tell you, this is a legend. And, of course, what we all are is humans, right? Software engineering is the act of developing processes to engineer around our own incompetence. And we are all struggling, and we're all very frustrated and annoyed by ourselves and by the world when we try and do coding. So I think, if I understand correctly, John's going to try and explain to us a bit today why it is that programming has to be the darned hard pain that it is. To do the formal bio, since it is, of course, one's duty in these circumstances, John is a senior software engineer at Google, and he's been involved in the C# community since 2002. So that's the formal introduction rather than the silly jokes. John.
Thank you. So as mentioned, I work at Google just up the road in King's Cross when I'm not working from my shed, and I work on making the Google Cloud Platform rock for C# developers. But I am better known for Stack Overflow, and I was really almost designed for Stack Overflow a long time before Stack Overflow came along. I used to post a lot on the C# and Java newsgroups and really sort of got the buzz from helping people. And if you read an awful lot of questions, as I do, you get to see patterns for what people don't understand. Even when there aren't actually duplicate questions, there are duplicate misconceptions. And that really sort of spawned this talk. I first gave a form of this talk back in, I think, 2009 at the Stack Overflow Dev Days in London, where I had my friend Tony the Pony, a little sock puppet. Tony's not here today. He's got a sore throat. It's fine. He's just a little horse. They don't get better, I'm afraid. But things have changed a little over the years. I've given this talk a few times, and it's changed a little in terms of where I want to go with what I want you to think about. So the title today is Problems in Basic Data Types in Computing, or as I like to think of it, we've messed up everything. There are very few aspects of programming which are all nicely elegant and nothing can go wrong. Now, today's lecture is probably different from some other Turing lectures. I decided to have a look on the YouTube channel and watch just a few clips, and there weren't many diagrams like that. There were sort of pretty graphs and sort of references to erudite publications and things, people being much cleverer than I am. there's hardly any tech to speak of in this talk. But I do hope that it'll give you something to think about. And in fact, because there's so little tech, for a change, I have actually written out some notes. This is not something I normally do when I'm talking, because normally if I'm talking about C#, I can waffle about C# for hours and hours on end without any notes. Just give me Visual Studio, I can bore you senseless. But I have actually put some thought into what I'm going to say today, because it's slightly out of my sort of comfort zone. And as a brief tangent, although it's not tech heavy, you might classify it as soft, in fact. And I use this word sort of in inverted commas. I dislike the idea of soft skills, because soft comes with a sort of slightly derogatory air. If you don't get a derogatory inference from the word soft, then that's fantastic. But I feel that sort of, you go to some conferences that say hardcore tech only, and clearly anything soft is viewed with some disdain. But I was at this conference in Oslo a couple of weeks ago, and I went to a mixture of talks, and some were hardcore tech, what's new in ASP.NET Core 2, and very, very well presented. But those talks, the tech-heavy talks, tended to be very detail-oriented and overrun their time. And since going to them, I've hardly thought about what the presenters said. I may well go back and watch the video again if I'm writing some ASP.NET Core 2 and I want to see, right, how did David Fowler do this after a few attempts? Because demoing code on stage is tricky, which is why I'm not doing any today. But it was really the soft talks that all finished early, and yet they sort of left a much longer lasting impression. They had very few questions afterwards, because if you're given something to mull, it takes you a while to think, well, hang on, how do I react to that? And that aspect of soft versus hard isn't really tangential to this talk at all, because what I'm talking about is how it's actually people skills, and I use that term very, very broadly, that are really difficult in tech. The actual typing at the keyboard, people sometimes sort of think, oh, I will use all the shortcut keys because that will make me much more productive. And I tend to say, I don't really have enough memory anymore for the shortcut for declare a property in 2 keystrokes, because I'm rarely limited by how quickly I can type. I'm always limited by how quickly and how well I can think. So I will be talking a little bit about how we've messed up on the computing side itself, but I really want to talk about people. And there are several kinds of people I want to talk about. So first, there's end users. If you're building an application, it's going to be used by someone. Then there are the people who provide code, so libraries and tools and operating systems. There will be other team members that you're working with. I'm kind of assuming that everyone here and everyone watching the live stream either is a software engineer or works with software engineer or is a bit of both. So there's other team members, and there's ourselves. And then there are, relevant to today's talk, but probably few other talks, there are all the humans who have ever lived long before computers were invented. They will be particularly relevant today. So our job is going to be to understand all those people. And I'm trying to convince you today that it's important that you try to understand all those people, and that it's hard to do so. You may have heard the principle of focus on the user and everything else will follow. I want to sort of broaden that a bit to understand the person and the software will follow. And I want to talk a little bit about diversity and normalization. This isn't about Unicode normalization or database normalization, and it's not a use of the word normalization I've really come across before a week and a half ago. Something happened that really changed a lot about this talk. I was reading some slides for a talk given by someone called Kylie Havelock who works in the Ministry of Justice, and she gave a talk on how she and her team, the team she's part of, were working to try to make that team more representative of the users that it was working for. And that talk, I've only seen the slides, I'm still waiting for the video to come out, it's that recent. But it struck a chord and made me revisit why all of this matters and what's gone wrong. There is no reason, I maintain, there is no inherent reason why software teams cannot be broadly representative of the users they are writing for the most part. If you are writing software to be used by 2-year-olds, then yes, probably you are not going to be on a team full of 2-year-olds. But for the most part, we're writing software that will mostly be used by other adults. And there is no reason why that has to be written by white middle-class men. It just so happens that that's the way things are, and that's one of the problems. So it makes it much harder for those teams to understand their end users, which means it makes it much harder for them to do a decent job of building software. So I want to apply that sort of basic idea to data types and to people who have never written a line of software and existed before software existed at all. Basically, I've been trying to work out what turns this kind of person, this developer, who is struggling with something difficult, and so they're trying to write potentially tricky software to solve a real problem, and they go from that to this. Open-mouthed horror, and quite possibly wanting to throw the keyboard from the previous slide through the monitor, and just, we've all had that feeling, and usually someone's to blame, and sometimes it will be this person, but often not. So I want to come back to the groups of people that we were talking about, because it's always people, it's never the computers. So let's first blame users, or humankind as a whole. So users of your software form just a fairly small part of the people that I want to blame today, because we'll see as I go through these examples that a lot of the problems of computing are inherent in the way that humanity has developed culturally and economically. But even if we leave aside all the people from generations ago, users are terrible, terrible people. If you have 2 users in a room, they will come up with 3 contradictory requirements and will swear blind at any one time that obviously that requirement shouldn't even need stating. This is if you can get requirements at all, and concrete requirements at that. It should be perfectly obvious that this will be the case, and it's absolutely necessary, and I can't possibly use your software if this isn't the case. And I also want this completely contradictory thing to be the case as well. And what do you mean they're contradictory? I can have it both ways. Okay, so we know we need to blame the users. Let's also blame architects, and I'm using this sort of in a broad sense as well. So not just people who would call themselves architects these days, but anyone who's providing software, compilers, libraries, operating systems, even the protocols themselves. Typically, they take a complex mess that has been, we blame the previous set of people, the complex mess of humanity. These architects study this, and they try to see the rules, they try to see the big picture, they stroke their beards a bit, and they come up with something that is actually just as complex as the original mess, but subtly different. It's still just as hard to understand, but it doesn't quite model the original. I'd like to apologize for the gendered stereotype here of guy with beard. I'm absolutely convinced there must be brilliant women through history who've made just as big a mess as well. And I don't want to be too negative. We're here for the Turing lecture, and I do want to recognize that for all the fact that I'm blaming people today, we stand on the shoulders of giants. Whenever we tap on our phones or type a key, the amount of stuff that happens and miraculously goes right is quite astonishing. It's a little bit like the first time you see a bike. You look at a bike and think, it's not going to work. Look, right, take the bike, leave it, it falls over. You're saying you want to go at sort of 15, 20 miles an hour on something that's just going to fall over? Yeah, well, going really fast, it's safe. What? And so it seems to be with software. We have this horrendous foundation of all kinds of things that just shouldn't work, and somehow the world keeps turning. So, after blaming the architects, I'm going to blame us common or garden developers. We've all had this. So we have sort of 4 basic problems. Firstly, we don't understand the complex model, the mess that's being created by humanity. Okay? We haven't bothered to think about what the users are really like. Then we also don't understand the subtly different complex mess that the architect has left us. We then, as a third thing, tend not to understand the application that we're trying to build. Maybe we've got a product manager who's tried to explain it to us several times, and we've just kind of got the wrong idea. Or we're in a team with several people, and we're all working on what should be the same application, but we think of it very, very differently. As an aside, if you ever get the chance to see the Vasa in Sweden, please do while you can. I think it's likely to only be around for another 40 years or so. This was a ship that sank on its maiden voyage after about 100 meters or so, and was just a fantastic project management failure in so many ways that if someone had told you it as a morality tale, you would say, no, that's just implausible. So it had people on the right-hand side of the ship, your right-hand side of the ship, building, and people on the left-hand side of the ship building. And they didn't speak a common language, and they used slightly different measurements. Like, it wasn't inches and centimeters, but it was the equivalent back whatever the day was. And then when somehow they built this lumbering ship that was told that the king said, no, there has to be more rows of guns than any ship before, because that's what I want. I don't really care about the guns, it just has to be more impressive than everything else. I think it was the shipbuilder said, do you know what, let's get some sailors to go up onto the top decks of the ship and run from one side to the other. And I was like, oh, look, it's gonna collapse, it's gonna fall over. What's the Admiral's response? Is it, okay, let's take this back to the dock and make changes? It was, no, stop them running from one side to the other. It's like, it's no wonder it sank. But it was all these many different people misunderstanding what they were trying to build with different measurements and different ideas. So that's our third problem. We don't know what we're trying to build. And the fourth is plain software engineering difficulties. Even if we understood perfectly what we were trying to build and for who and the architecture on which we're building it, frankly, bugs happen. They certainly do in my code. So against this backdrop, I'm going to talk about 3 things: numbers, text, and dates and times. That's, dates and times is sort of one thing. Chronological types, if you like. So first, let's talk about numbers. You would think if there's something that computers will get right, it will be numbers, because everything else is built on that. And I'll be fair, the numbers here, integers, we can mostly manage integers. Some people will get a bit confused the first time they see an overflow. You know, I've got a 16-bit integer, signed integer, and it overflows from 32767 to minus 32768. And it's particularly weird when you do the negative of minus 32768 and it's still minus 32768. How does that happen? So there are still some problems with integers, but they are nothing compared with floating point. Oh boy. How is it that we can search web pages, the whole web, in milliseconds, and yet every other day there's a question on Stack Overflow saying, why doesn't arithmetic work in .NET or in Java? It's typically either, I've got these numbers and I'm adding them together and the answer's wrong, or I'm dividing these 2 integers together and assigning the result to a double, and it's always 0. Well, yeah, you're doing integer arithmetic and then doing the conversion. And if it's the first time you've thought about it in those terms, I can completely see why it's happening. What I don't understand is how we haven't fixed how people learn programming so that not everyone has to discover that by being surprised by it. So, how is it that we've ended up with broken numbers to start with? I blame evolution. This is just plain wrong. We have 8 fingers and 2 thumbs. This was a mistake which has led to a lot of suffering. Life would have been much simpler like this. Okay? So at that point, we can count in base 8. Okay, we'd only have 3 bits of information, and that's not ideal. So in some senses, maybe it would be better if we had 7 fingers on each hand and a thumb. So we'd be able to count in base 16. You know, we're all comfortable with hex. It kind of feels like a nice base, but I'm not sure all those fingers would be practical. And certainly, if you go to the other direction of, you know, only having 2 fingers and 2 thumbs, certainly typing on the phone ends up being complicated. But you know, with 8, it would have been reasonably okay. And in fact, this was something we had the opportunity to do already. Even with our terribly designed 10 fingers, or rather 8 fingers and 2 thumbs, there's nothing to say we had to count using all of them. Why not count with 8 fingers and keep the thumbs as parity bits? You'd be able to tell, oh no, I haven't got my thumb down, I should have the thumb down. You know, we could have error correcting within basic arithmetic. It would have been great. So, to make this more concrete, what does this line of code do? You can think of this as C# or Java, probably C. It's been a long time since I've done C, I'm very glad to say, and probably a bunch of other languages. So, what does this do? What is the value of D after this line of code executes? You're all smart people, so you know it's not 0.3. Okay, it's clearly not going to be 0.3, but what is the value? It's this. And importantly, it is this exactly. So one of the dangerous things is a little knowledge. And I see this on Stack Overflow all the time, where people say, no, you shouldn't use binary floating point. It only has approximate values. No, it doesn't. The value of D really is exactly this. When people say a decimal value is exact and a double value is an approximation, or a double value is approximate, they've got a bit mixed up. They're looking at things from too human a viewpoint. It's no bad thing. I'll come back to that in a minute. But it really is an exact value. It's an approximation of 0.3, but it is exact in itself. And this hints actually at a sort of deeper problem that I see time and time again, which is people getting confused, understandably, between what they see on the screen and the data that is being represented. And I would urge you, if you're relatively new programmers, to really take this on board and think, is that something I come across as well? So imagine if debuggers, or even double dot to string, if when you printed out D, it didn't print this, and it didn't print 0.3, but instead it printed the binary representation with a binary point in, you know, 1.00111 times 2 to the power 15, whatever it would be. At that point, no one would say that's only an approximate value. It feels more real because it is exactly what's being represented. Of course, most of us aren't sufficiently familiar with binary floating point or binary in general to be able to convert mentally between, well, you've got 101.111 times 2 to the minus 5. Well, what's that in real money, as we'd say? Yeah. Oh, it's 0.2, whatever it is. So you'd need some kind of decimal representation. But basically, looking at the string representation, it's not lying to you. Well, the debugger, if the debugger shows 0.3, which it probably would, that is lying to you. And if it shows this, then you'll think, well, why is it showing me that instead of 0.3? But debuggers do lie. One of the problems that we very often see on Stack Overflow is someone saying, how can I get the double backslashes out of my string? So they say, I've got this string, and they can provide a concrete example, and it's great. And they say, I look in my debugger, and it's got C:\\/ / program files \\\. And I've tried getting rid of the double backslashes. I've got text equals text.replace, verbatim string literal with double backslash, with single backslash, and it's showing me exactly the same thing. It's like, yes, your debugger is lying to you. Sorry about that. It helpfully decides to escape the strings for you. Likewise, even with integers, this is a problem. We see people ask, how can I convert a decimal integer into a hex integer? There's no such thing as a hex integer. There's the hex representation as a string of hex digits, or the decimal representation as a string of decimal digits. But really, it's just a number. If I show you 32 llamas, then yes, as decimal, that's 32, and as hex, it's 20, but it's the same number of llamas either way. If you think of it as it's the number, not some arbitrary string representation of it, you'll get better. I'll come back to that when we talk about dates and times, because I've got a big rant on that front. So, we have binary floating point. And I don't want to underestimate the value of decimal floating point types, having just said that people don't quite understand the difference. And I used to just kind of leave it at saying, well, these two types of numbers are different. One is artificial. £5.50 is exactly £5.50, whereas 5.50 kilograms is a measurement, really. Nothing's going to be exactly 5.50 kilograms because we're talking about physical quantities that are effectively on a continuous instead of discrete scale. And unfortunately, while that is the appropriate way to use floating point types, it kind of leads to the myth of, well, decimals are exact and binary floating point is an approximation. Well, no, it's just that when you use them, it's useful to use binary floating point when the result is already an approximation. I said before that saying that decimal is exact is looking at things from the human viewpoint, and I stand by that. But I think if we had put the needs of humans first to start with, we probably wouldn't have had binary floating point at all. Imagine if we could wipe away years of history and put all the computer science effort, which has been considerable, I'm sure, largely in hardware, all of the effort that's made floating point incredibly fast in hardware, binary floating point. Imagine if all that effort had gone into making decimal floating point incredibly fast. Imagine if programming languages had decimal floating point built in. C# has the decimal type, but you have to kind of explicitly use it. Imagine if we'd done this by default. Imagine if IEEE 754, which I was quite astonished to see just how recent it was and how many different forms of binary floating point there were stretching across time. But if we'd started with decimal floating point, and possibly if future programming languages start with decimal floating point, I think we'd be in a better place. And this comes back to thinking about what people want. So let's think about the users of floating point types. Typically, there are business people using it for currency like this, and there are scientists using it for physical, real-world quantities. So business people typically want to be able to specify really clear rounding features. So, if I divide this and it doesn't quite work out evenly, then give me the change. Typically the financial institutions. And scientists want to be able to cope with very, very large numbers and very, very small numbers. And numbers in between, but numbers that are far bigger in range than anything even the most enthusiastic banker would ever expect to need. And game authors, well, they probably want a bit of both. You know, maybe you've got your role-playing game and you've got an attack of 6.6, but you've got a distance from here to the next target as well. So they're going to have a mixture of both. But if we ignore the performance aspect, there is no contradiction between any of those requirements, and if we use decimal floating point for everything, and acknowledge to start with, say, we're humans, and the computer should be working for us. And tell you what, let's find out what our users will want and what developers will expect. If we'd taken that as the starting point, rather than how can I really efficiently represent numbers, you know, with as few bits as possible, then I think things would be different. And as I say, I think it's still possible now, because I believe in the power of defaults. So at the moment, if I look back to this code, there is no suffix at the end of 0.3. Imagine if that didn't compile. Imagine if you had to put 0.3d. There are two options. We could either say, well, every floating point literal has to have a suffix at the end. So at the moment, you could use m in C# and it would be a decimal. Or maybe we just make decimal the default for literals that didn't have a suffix. And the reason I'm pretty sure that would work is when you look at virtual methods in C# and Java. These are the two languages I know, basically. I'm really keen on the idea of polyglot programmers. It's just I'm not one myself. If you're a web developer, you know more programming languages than I do. Pretty much guaranteed. But I do know Java and C# pretty well. And in Java, methods are, there's no real term of virtual methods. There's just methods and final methods. But if you think about methods you can override and methods you can't, then in Java, by default, you can override things. In C#, you have to say virtual method, and I'm trying to override it in a derived class. Now look at code bases in Java and C#. The languages aren't so different. They're really quite similar in some ways, apart from C# is much better. It really is. They're not so different that you would design classes massively differently. If you want a virtual method in Java, you probably want a virtual method in C# and vice versa. But if you look at real-world code, you'll find that 90% of the time, let's just go with the defaults. We sort of can't be bothered to think about it. So you won't see people sealing methods in Java unless they're being really dedicated, and you won't see people making all the methods virtual in C# unless they're differing in their tastes than me. I think C# went the right way. I wish it sealed classes by default, but that's a whole different discussion. The point is, unless there's a really compelling reason, or even if there is a really compelling reason but people can't be bothered to think about it, they will stick with the defaults. So if this didn't compile, people wouldn't use it, kind of by definition. But if this didn't compile and decimal d equals 0.3 did, they would probably be using decimal, and most people would be happier with that. Okay, I think that's enough about numbers. Let's talk about text. So this is a very different problem, and it has very different roots. So some of you, I'm sure, will have encountered at least some pain dealing with text. And I'm not going to try to provide an exhaustive list of everything that can go wrong. I'll give a few examples, but first I want to think about some of the historical reasons, and I'll loop back to this at the end. So this slide shows two isolated islands, each with people talking to each other, and each island has its own language, which is sort of being represented by a character set in this case. The text on the right-hand side almost certainly means nothing. I certainly hope it doesn't mean anything offensive. I picked some katakana characters that I would be able to draw. And just as sort of a meta observation, the fact that I'm not aware of what it means and that I was too lazy to find someone who was a native speaker to say, could you just give me some characters which won't offend anyone? That's on me, that's a fault, okay? It's very easy to be lazy and potentially culturally really insensitive, and it's something that we should, as a community, fix ourselves. However, the important thing is that these islands are not talking to each other, at least not in this slide. So imagine through history, why do we have lots and lots of languages? Because people developed communities and they sort of melded and sent people away to meet other communities, but they were sort of mostly isolated in development and rejected the idea of homogenizing. So we have multiple languages, we have all kinds of different cultures. Each of those communities, if you are asking for representative users, if you tried to make, if each of these were developing software and each had to have a team representing its users, the island on the left would have ones using Latin characters, the island on the right would have people using katakana characters. If you ever tried to sell the software from one island to another, it would fail cataclysmically. And part of the problem with computing is that it developed when this was the case, somewhat, much, much more so than now, but it enabled the vast sharing we see now. So it is sort of a victim of its own success. To put it another way, I would really like to think that if we had started off with the sharing of cultures that we have now and the acknowledgement and recognition of how different cultures deal with text, then I'd like to think that US ASCII would never have happened. It's a problem. It was the economic inequality that meant that a lot of computing did develop in English-speaking countries, and they decided just not to care about anyone with accents on their names. And so computing is effectively in English today. And there are benefits, I'm not going to make any bones about it, there are certainly benefits to a monoculture in terms of everyone speaking English. It means I can go around the world and give talks in all kinds of different countries, because if you're a software engineer, you have to understand English. I probably won't be able to understand anything you say on your feedback form, but you'll be able to understand me. And that sort of shows my poverty. So it's great in terms of if you learn one language, English, then software engineers will be able to understand each other, but it's terrible for representing members of other cultures. So there's more to text than just cultural problems and encodings. Let's have a look at this code that's meant to reverse a string in C#. It doesn't look too bad. It's reasonably efficient, but it's broken in at least 3 ways. Let me show you one of them. So, Les Miserables, one of my favorite musicals, saw it a couple of weeks ago. How do you write that E with an acute accent? There are at least 2 ways in Unicode. You could either use the E acute character, or you could use a regular ASCII E followed by a combining character representing an acute accent. When I first did this slide, a long time ago, I had that \U0301 before the E, because I thought, well, what's the easiest way of making sure I've got this right? I'll write a little Windows Forms application and pop up a message box with it, and it happened that putting the accent before the E worked out correctly. It's a shame that the Windows Forms folks, or possibly Windows itself, had got it wrong. This is an example of where tools fail us again. So, imagine that we've got that string now in the correct format, E followed by an acute combining character. What happens when we try to reverse it with the code that we got before? It's reversing it char by char. It's just calling an array.reverse for the char array. So what we end up with is an R followed by the combining character followed by the E, so we end up with the accent on the R. That is clearly not the reverse of Les Miserables, character by character, not character by character as users would think of it. So that's one problem. Now imagine that actually you weren't writing Les Miserables, you were writing some Hebrew text that included some parts that was left to right, and then a bit of Hebrew that was right to left, and then some more left to right. I honestly don't know what would happen if you tried to throw my primitive text reversal thing at that. Who knows? Finally, third way in which it's broken is with non-basic multilingual plain characters. If you haven't heard about the basic multilingual plain, they are the first 65,536 characters of Unicode, back when we thought that 64K will be enough for anyone in terms of characters. Well, when it turned out that it wasn't, the Unicode consortium said, okay, we can handle this. We've got the idea of UTF-16, which is an encoding where each code unit is 16 bits, so it's sort of fixed width, except we've got this reserved bit. We'll split that into two and say any characters you want to represent outside this 64K chunk will represent with two UTF-16 code units, a high surrogate and a low surrogate, or possibly the other way around, I can't remember. But the point is, those would be two chars, because a char in .NET and in Java, and I think in JavaScript still, is a UTF-16 code unit. So if you try to reverse them, you get the high surrogate and the low surrogate the wrong way round. So it's no longer valid. Maybe reversing text isn't a terribly useful thing to do, but sometimes counting characters can be. How many of you have ever seen a web form saying, okay, fill in this summary of why you came today with a maximum of 200 characters? Any text field with maximum of a certain number of characters. We've all seen it, right? How many of you have seen a form saying, fill this in with a maximum of 200 characters in Unicode normalization form, KCD or whatever, and it's 200 Unicode characters, not UTF-16 code units? No one writes that, but probably some code is going to be dealing with, if you ask for a string.length, that will give you one answer, and that if you count the number of Unicode characters, that can give you another one, and then if you decide that normalization form with this sort of thing, does that eacute count as one character or two? Well, depends on your normalization form. You have problems. I used to be able to say, don't worry about text outside the basic multilingual plane, you'll never see it in your application. And then teenagers came along with emoji. And now, probably every single one of us, every single day, uses applications and sees characters outside the basic multilingual plane. And not only that, but they've got their own combining characters as well. So you can have an emoji with a particular face, and then something indicating the sort of racial makeup of that face to indicate what sort of tint to put on it. So you could have something that's actually 4 UTF-16 code units, but shows up as one character. How's your length field going to deal with that? My guess is inconsistently. One next problem, back in ASCII. You all know where we're going with this. So these are mostly cultural things introduced by people inventing text a long time ago and coming up with different right to left or left to right or up top to bottom schemes. But this is entirely of our own making. This is within computing. So line breaks can be carriage return, line feed, carriage return, line feed, or just to get in on the act, Unicode's own line break, because why stop at 3 different ways of doing it? How many thousands of hours have been wasted on something exactly like this? I'll tell you, this is still a very real problem. My colleague and I back at the office were discussing just today enabling something called SourceLink for the libraries that I work on. And that's basically a way of saying, well, this library, this bit of code comes from that Git repository and that file within it at that commit. And that's great, but in order to work out whether the files match, they get hashed, and they get hashed with Unix line endings, which means when you compute the hash, You need to have Unix line endings as well, which means you need to change your git autocrlf setting when you check out and clone the repository, etc. And it's sufficiently complicated that we've said, oh, we'll do it when we've got some more time. Okay, this is a problem that we started a long time ago in computing, and we have persisted it. Finally, here's a bug that I wrote, actually not quite finally, a bug that I wrote quite a while ago, back in about the year 2000, I think, which actually isn't quite as long ago as you might think. I had an email yesterday saying, hey John, I've got some code, or rather I would like to have some code that you wrote a long time ago that my organization is still using but we no longer have the source code for, or we've only got part of the source code. I can't remember writing this code at all. It was, here's an open source library for Complang Java programmer. I have no memory. Apparently I did. You know, the guy sent me a quote for the comment, and it certainly sounds like me, but I have no memory of it whatsoever. I remember this quite vividly, though. We were working on a sort of mail client, a mobile thing, and I had some headers, I think in a property file, and I checked whether the key, so although it says value, it's really the value of the key, was mail, and I wanted to do it case insensitively. So this was the code that I used in Java. And everything worked fine. And then we had our first customer in Turkey. Anyone familiar with the, if I say the problems of Turkey, I mean solely in terms of capitalization and case comparisons? Yeah, a few nods. If you're not familiar with that, there is a page somewhere, I'm sure, called the Turkey test. Every time I look for it, I can't find it. But basically, if you uppercase either a lowercase ASCII I or an uppercase ASCII I in the Turkish culture, Turkish locale, you get an I with a dot on it. And likewise, if you lowercase a regular ASCII I, you get a lowercase I with an accented dot on it, I think. So this doesn't work. You need to either say to uppercase in the invariant culture, the root culture or whatever, or use a different way of performing case-insensitive queries. Yeah, I remember quite vividly, this took a surprising amount of time to track down, and then I had to look for everywhere else in the code base where I was using uppercase and say, well, what am I doing? Fundamentally, we're using strings for both computer-centric values like this. You know, I didn't expect any user to ever see mail, so I shouldn't be thinking about it as a user. I should be thinking about it as the computer. Whereas other bits of text, free-form text, you probably can't do anything with that. You know, if you convert it to uppercase, you will be doing the wrong thing sooner or later. So that's one of the problems of text, is we use it for two completely different purposes, but usually we just have one string type. Finally, genuinely finally this time, this was a problem that I saw on a newsgroup. So this is some fairly inefficient code in C# back a long time ago before we had the contains method to try to reduce white space, to go from two spaces or multiple spaces in a row down to a single space. So the first argument to index of here is two spaces. The first argument to text.replace is two spaces. The second argument to text.replace is one space. Any thoughts about what could go wrong with this? Other than, you know, it could take a very long time and allocate lots of strings. That's at least correct. Nope. Well, you clearly haven't come across this character. This is an atomic zero-width non-joiner. Interesting little Unicode character. And it's a hint that the two characters either side of it shouldn't be squashed too closely together. Unfortunately, now which way around it was? Yes, index of. So if you imagine you've got that, so it's got a space either side of that zero-width non-joiner. Index of ignores it, pretends it's not there, so it will find the index. Replace doesn't ignore it, so that can't find the double space, so this is an infinite loop. Kind of surprising, isn't it? What's the bet that some of your code might have problems there. So let's sort of take a step back again. I do want to focus on the humanity of things. What's caused the problems here? So there is humanity itself. Cultural diversity makes software harder. That's bad. On the other hand, cultural diversity enriches humankind so much that I wouldn't want to be without it. We could be in a world where software development was much easier if everyone only spoke English, if there was only English, if there was no such thing as an accented character, and if US ASCII really was enough for everything. That would make life much easier. I'm very glad that we don't live in that world. There is just too much at stake to have a monoculture. However, we do have a lack of foresight because we don't think of each other. If people working in computing in the 60s or 50s or whenever ASCII was invented had thought, do you know what, maybe it's kind of rude to not let people write their own name in the character set I'm creating, then we wouldn't have nearly as many problems around encodings and things. Now, to some extent, I do understand that enabling more possibilities has costs. Back when, saving a byte here or there, or maybe saving 2 bytes so you just record a year without the century on, when there were real costs to having foresight. But I think a lot of it is just, well, nobody I know has an accent on their name. Nobody I know has a name written in Cyrillic or katakana or all of these things. So I will just assume that they don't exist or they don't matter. That's what we've effectively said, and it sounds horrific when you put it that way, but that's what we've done. Then there's the incremental complexity of things like emoji. I don't know how you get around that, but it's there as a problem. And finally, there's the tooling that can lead you into a false sense of security, as I had earlier on. So that's where we're blaming the architects again for, yep, they've come up with Unicode, which is overly complicated to start with and has this sort of zero-width stuff that's a pain. And also, the tools that use Unicode don't properly understand Unicode either. And then we're trying to use both of them at the same time to try to understand a problem that we don't fully get either. I will say, if you have a global team, you're less likely to have these problems, because, or rather, you will find them quicker. So, again, apologies if I'm hammering this home too far, but if your team represents your users, then they will see the problems that your user will see, and they will probably value those problems. If you're writing a word processor, and one of your team members is unable to write a letter home, you're going to fix that. Whereas if you get a report from some user you don't know personally, saying, why don't you support this language or this feature of a language, it's human nature to ignore that to some extent. Right, enough about text. Finally, let's talk about time. Wrong slide. Okay, what is the time? Am I? Okay, wow, I've taken longer than I expected. I am biased when it comes to date and time problems because I maintain a date and time library, Nodetime for .NET. I've seen a lot of the problems. But I can just say that your date and time code is wrong. Almost certainly. The chances of me being wrong when I say that your code that deals with date and time, unless you don't have any, it's quite easy to have entirely correct code if you don't have any code that deals with dates and times. But almost everyone, certainly in business applications, science, it's probably a bit easier, but anyone dealing with businesses, it's going to be harder. So let's have a very quick look at what makes date and time stuff hard. Firstly, let's get rid of relativity. Okay, we don't care about that. We like simplifying things, and we know that relativity exists, but not many business applications care at the moment. They will start to care when we have shuttles going to Mars, and you need business calculations of how much to charge customers based on how long it takes to get there, and that can change depending on how fast they're going with relativity. But for the moment, let's ignore it. Let's also ignore leap seconds, because unless you're doing GPS stuff, you probably don't care. But let's think about calendars. So I could rant for a very, very long time about date and time, but there are a couple of aspects that I want to emphasize. One is calendar systems. This is probably the Gregorian calendar system. You may have heard of the Gregorian calendar system. You may have heard of the Julian calendar system. There are lots more. Those two are both nice. They're kind of predictable. There are other calendar systems where your new year depends on whether the calves are fat enough to kill for the feast that you're going to have for New Year. If they're not fat enough at the moment, oh, we'll just wait a month. We'll have an extra month, and then we'll have a New Year celebration later on. Or maybe you can't see the moon from your particular place because it's cloudy. Can you imagine trying to organize meetings that depend on whether 3 days' time it's going to be a cloudy night? It makes no sense. Interestingly, calendars, I think it's interesting anyway, calendars are probably the greatest intersection between computing and religion, because for whatever reason, maybe it's to do with the ritualistic nature of religion, religions have tended to dictate calendars. And that can be quite unexpected how it intersects with computing. So take UUIDs, for example, the sort of standardized UUIDs. They have a timestamp in. Does anyone happen to know what that timestamp is based on? You know, timestamps tend to be based on an epoch. Usually it's the Unix epoch of 1970 midnight UTC, which wasn't midnight Greenwich, the time observed at Greenwich at the time. I'll come to that in a minute. But most things are the Unix epoch. UUIDs come from October the 15th, 1582, which is when Pope Gregory XIII declared that Catholic countries in Europe would change from the Julian calendar to the Gregorian calendar. And for whatever reason, we've got that information embedded in UUIDs. I find that quite remarkable. I find it even more remarkable that some other countries decided to change from the Julian calendar to the Gregorian calendar at other points, and Sweden had to try to do it twice. They got confused the first time they did it. They got confused because they went to war. They were going to say, we'll have no leap years for quite a while, and that will sort of gradually bring us from the Julian to Gregorian calendar. And then they missed out one, and then they forgot for a while, so they accidentally had 2 leap years. So they were now 1 leap year behind the Julian calendar, and still a long way to go for the Gregorian calendar. So they decided in 1812 to have a double leap year. So that's the only time that I'm aware of February the 30th. Only in Sweden, only 1812, and I love that. However, even without oddities of switching calendars or observational calendars, calendar arithmetic is still fiendish, basically, because it's so counterintuitive. Suppose you had a friend called Chris who was born on February the 29th in the year 2000. Well, for one thing, half the software you use would reject that as his birth date because they would think that February the 29th didn't exist. It really did. Okay. What happens February the 28th next year, 2018? Can Chris go for a drink? To some extent, if you said, right, well, what was the date 18 years ago? Oh, February the 28th, 2000. Chris hadn't been born, therefore he is not 18. Seems reasonable. Sorry, Chris, can't go out. On the other hand, if you take Chris's birthday, February the 29th, and add 18 years to it, what's the result? Maybe it's March the 1st, 2018. Maybe it's February 28th, 2018. In the latter case, yeah, you're 18. This is when you celebrate your birthday. Great, we can go out. My guess is that different countries will fall into one of 4 camps. 1, they don't specify, so the law is kind of interpreted however people want to. 1 is maybe they consistently say, well, your birthday counts as the February 28th in a non-leap year. Maybe they say okay, consistently, your birthday is March the 1st. Or fourth, and probably most likely, is different laws will take effect at different times. So maybe you can have a drink but not vote, or vice versa. I really hope we never end up with a general election or something on February the 28th. Because anyway. So arithmetic using calendars is inherently odd. And then we have time zones. Not that these are actually time zones. They're sort of time zone abbreviations, but actually what they're abbreviating aren't time zones either. I'm speaking slower than I expected to, so I won't go into all the details of time zones, but I will point out an interesting thing on this slide is that CST occurs 3 times. One of those is Central Standard Time in America, one is Central Standard Time in Australia, and one is Central Summer Time in Australia. Oh, we're laughing at the Australians, are we? What do you think BST stands for? No, it's not British Summertime, it's British Standard Time, which was what we observed between 1968 and 1971. It was still UTC +1, not that UTC existed back then, but it was all year round, so it didn't have any daylight saving time component. And we decided to use the same abbreviation as well. Yay us. And this isn't, you could say, oh, these are corner cases. No one actually runs into it. No lie, just today, I ran into a Stack Overflow question saying, I'm parsing this date that ends in IST, and it's giving me the wrong time zone. It's giving me Asia/Jerusalem as the time zone. I want it to be India/Delhi, or whichever it is. They thought it was Indian Standard Time instead of Israeli Standard Time. And someone helpfully popped up saying, are you sure it doesn't mean Irish Standard Time, which is another one? That happened today. It's confusing people now. Don't use these as identifiers. They're not identifiers. They don't identify anything. So yeah, daylight saving time. Time zones themselves make a lot of sense to me. I can understand why people like the idea of 12 o'clock is when the sun is above your head-ish. But what have we done with time zones? I don't think there's any really good reason for daylight saving time. It's been proven not to have the effects that were desired in various ways. So there can be human aspirations that are reasonable. I think it's reasonable for humans to divide time up into manageable units, years, months, weeks, days. I think it's reasonable to have time zones. I would like the time zones to be better controlled. I would like it not to be a volunteer group who effectively provides the data that every Unix system in the world uses for what's the time in Dubai right now. That feels like it should be a little bit more official than a bunch of people doing it out of the goodness of their heart. And occasionally, if you look at the time zone database comments, it's spectacular. There had to be a correction a few years ago because one dedicated researcher had called someone in the, thinking they were calling the mayor of a particular town in the US, I think it was. And it turned out they'd accidentally called someone in the neighboring state. And they hadn't said to check, they'd just said, right, what's your local time now? Because they called the wrong person, we ended up, everyone in that little town would have had the wrong time on their computer for a while. Like, this shouldn't be left to a bunch of kind-hearted volunteers looking at websites and saying, well, you know, our rules say we've got to have something from a government in English. We shouldn't be looking at the Egyptian government's Facebook page to make changes to the database the day before they say that they're going to change daylight saving time. That's the kind of thing that happens. You can wander through airports where some of them have updated to the latest version of the time zone database and some haven't. So is it 10 past 3? Is it 10 past 2? I'm in an airport. Time clearly doesn't matter there. It's like, not like any flights are going to be changing. Okay, so that's dates and times from the human perspective. What about from the technical perspective? Well, the good news is that all platforms and all languages have rock-solid, incredibly easy-to-use date and time types. I wish. My main exhibits are Java util date and calendar, system.datetime, and JavaScript date types as well. These have been recognized to be so awful, at least in the case of Java, that Java now has a much, much better set, java.time. .NET has no-time because I just couldn't stand to see Java have Joda-time and not have anything better for .NET. And the JavaScript world, the ECMA standardization committee is working very hard with a couple of friends of mine to make time significantly better. But we have these appalling abstractions in the base class libraries for really complicated things. So this is the classic example of complicated system that frankly no humans understand properly, and then an entirely different, also complicated, also wrong way of modeling it, and then developers who then don't understand it properly. I mentioned that I would come back to the idea of your debugger lies to you. If you call to string on a Java util date, it will say, oh, it's this time of day in IST. Like, well, that's not what the Java util date represents. The Java util date represents an instant in time. It's not in a particular database. That's not part of the information in it, just like an integer doesn't know whether it's in hex or in binary or in decimal, because it's just a number. A Java util date is just a point in time. But sadly, that information, however often it's repeated by those of us who do know, seems to get lost somewhere. And likewise for other platforms. So there's plenty of blame to go around, but the end result is that if you look at code dealing with dates and times, it's like there's a screw and you're trying to drive the screw with a hammer, but you're throwing the hammer from a distance with a blindfold on. It's just not a recipe for success. Okay, I've overrun massively, but I'm still going to do a little digression because it kind of comes back to my first point about Kylie Havelock's slides on diversity and normalization, and actually a second set of slides that she happened to tweet on this topic. I was mulling over, / panicking over, this talk last night as I was on my way back from Zurich. I was in the airport, I needed the bathroom, and I had to make a binary decision. I chose the men's bathroom, and it suddenly struck me that I've talked about integers and floating point numbers and text and dates and times. What is the simplest type that we have in computing? The Boolean. True or false? 1 or 0, however you want to think about it. Now, fortunately, Booleans rarely surprise developers. So you might think that they don't deserve to be in this talk at all, until you think about how often they're misapplied. In some ways, it might be better if we didn't have such a simple type, because the world is very, very rarely that simple. When we try to model the real world using something that is only on or off, so often that strict binary choice doesn't represent reality, and our users suffer for it. Clearly, in this case, I'm thinking of gender, and there are whole blog posts about how you can properly, inclusively, and sensitively write applications that will cater for not just people who identify as men and women, but non-binary, gender fluid, all the whole spectrum. But if we didn't have this, it's so simple. I can model most of the world just by saying true or false, man or woman, whatever it is. Then we wouldn't leave out all those other people. So, I want to conclude by being a bit more positive. I've been very negative about how everything's broken. But as I said earlier on, somehow the world still turns. We still manage to write software that kind of by and large works. I would like us to do better, and I think the way to do better is not just to learn how to use containers better. It's not just to write more efficient code. Ultimately, if we can understand people better, we will write better software that will be better for them. If we try to make our teams represent our users, we will end up with more heterogeneous teams, which will in turn break down some of the barriers that make that hard to do to start with. So it will be hopefully self-perpetuating. The more we pay attention to this joyous mess that we call humanity, if we acknowledge that it is a mess, and there are reasons why it's a mess, and we should celebrate that because, yes, a simple world would be one where there's only one language with limited symbols. But if we didn't have all those authors and sculptors and painters in all kinds of different contexts, then we'd be in a much, much poorer world. So if we start putting human needs above the needs of computers, if we start writing code that speaks to humans, speaks to other developers, and happens to compile and do the right thing instead as well, instead of saying, well, it compiles, I have tests that prove it works, therefore it's done. If we pay more attention to the human needs, we will be better. Within the purely text space, we can do that thinking that other developers are our users. Build tools that cater to the probably imperfect models that other people have. Document what you think your model is. You don't need to understand relativity to save a timestamp to a database. But it's often helpful to understand just a bit more than you think you absolutely need for solving your problem. Maybe if you push your own boundaries just a little bit, try to understand someone who may be on an edge case. Maybe you can live without that customer. But if you can understand their needs just a bit better, maybe you can cater to them as well, and everyone benefits. So we're unlikely ever to make software not messy, but with determination and, far more importantly, empathy, we can get there bit by bit. Thank you. And somehow 45 minutes becomes an hour and 10 minutes. Apologies for those of you with other deadlines.
Let's do questions.
Yes.
If we're going to skip anything, let's just skip you and I having a chat and do the room. James Geddes.
Right, and if you wait until you've got a microphone, that will help the live stream, and I will repeat questions for people in the room who may not be able to hear otherwise.
Thank you very much indeed. So you've sort of outlined, one good reason why our code is imperfect, which is that we just sort of didn't think or understand or weren't aware of other ways of doing things, or the variety of human messiness. There's another reason, prosaic reason, which is, we have to ship. So for example, my favorite language, which I won't tell you what it is, did think very carefully about lots of the issues you mentioned, not all of them, but numbers certainly, and strings certainly. But no one I know uses my favorite language because in the early days it was too slow, and now, by the time it got it right, there was JavaScript and Java and so on. Mm-hmm. What would be your advice on coping with that other sort of incentive or constraint on getting it right?
So to summarize the question for those who couldn't hear, I've talked about thinking deeply and carefully about human concerns and really paying attention to ultimate needs. But that can come at the expense of shipping, and if you don't ship anything, no one's going to use it, and if you ship 6 months late, very few people will use it. There's no point in shipping the perfect thing late. Do I have any advice? I'm just going to take a little drink. I think that's a question for wiser heads than mine. There is an aspect to, if I understand the problem space, then I don't need to solve it, but I could write a solution for most of it that doesn't preclude the rest of it later, sometimes. At least you've got a much better chance of not getting yourself into backward compatibility problems, and I could do another whole talk about versioning. It'd be very dull. But you can, you can avoid backing yourself into a corner at least better if you know the problem space better. So I'd say that's probably the balance to strike, is take the time to understand the needs of the users that you may not address yet, and then you can aim to address them later on. It's not always going to work, and frankly, there will always be priorities. And how do you prioritize? Well, I've got 10 people over here who are probably desperately underserved by all of software, but who would like my product if I just catered in this particular way, versus, hey, I can add just a feature that's a nice to have, but it'll be nice to have for 1 million users. I don't know what's better. And this is why actually laws around accessibility are useful, because governments can force you to do something that may not be for your company's good, but is for the greater good. And I'm pleased about that kind of thing. Great question, though. Wish I had a better answer.
Thank you.
So one of the, nice question. So your point about trying to get a representative team of developers,
Mm-hmm.
so that the complexities of the world are represented in the concerns that are of importance to people doing coding. One of the ways we would like to be able to do that, right, and have a team that scales to the complexity of humanity would be through big open source projects. Mm-hmm. And yet there's been some very interesting recent data coming out of GitHub that shows just how bad our diversity problems are on open source projects.
Yep.
What can we do to, what is in particular the problems of sort of volunteer projects from this as opposed to paid projects? Because you do a lot of work, John, in both volunteer projects and paid projects. Which one do you find there's more of a problem?
Oh, that's a good question. I don't see much of it myself, but I know it happens. Unfortunately, that means that I'm not in a good position to say, well, more of it happens that I don't see over there than what happens over there. Okay. I think we first need to acknowledge that it is a problem, and also, actually, I would like to say that if you pay attention to people, to your users, in the way that I've been describing, then, hey, maybe you'll think of other people as well. I have a t-shirt saying feminism is the radical notion that women are people. And the more we can try to empathize with people, with users who don't represent us now, but hey, maybe if we reach out to them, then we can write better software for them and become better at working with people like them, then that's part of it. Within a company, yes, you've got an HR department who it would be nice to think could stamp on sexism, racism, homophobia, whatever it is. We know that while I'm sure that's the aim of all HR departments, life doesn't always work that way. Likewise, we can have codes of conduct within open source projects, which may sometimes have teeth and sometimes not. I think those of us in positions, aspects of privilege, need to get better at calling other people out, is probably the very first thing. If you see someone being a jerk, say you're being a jerk, and more forcefully if necessary. Yeah, if I could solve the diversity problem in a lecture, then that would be fantastic. Or as other people would put it, the normalization problem. So I didn't really talk about what normalization meant here as a word. It was actually Shonda Rhimes gave a talk to HuffPo a while ago about this, saying that with TV programs like Scandal, etc., she didn't think that she was diversifying TV because that makes diversity sound like a sort of snowflakes problem of, oh, we'll add a few people there and a few people and token people. That's, to her, the connotation of diversity, as I understand it. Whereas normalization is saying, well, do you know what? If 90% of TV is run and written, etc., by men, then that suggests that that's what's normal. But no, that's not normal. So she's trying to normalize TV by saying, do you know what? Half the world is women, so probably half the people writing TV shows should be women as well. So that's the aspect of normalization that she's talking about. And I think to some extent, I hope we're making progress. It will be very, very, very hard, and I hope it gets slightly less difficult over time.
On a lighter note, one of the things I enjoyed most about your talk was the lots of comedy examples of different things that are irritating in code.
I wish they were comedy as in unrealistic, but these are all things that actually happen.
I was thinking probably with the audience here of people who work in quite a wide variety of different areas, we might be able to give you some more anecdotes for future things. So I've got some interesting ones from a project we're doing about date time problems in ancient Assyria, from the open richly annotated cuneiform corpus, which is a database of tablets dug up in Iraq. That's quite fun. Anyone got any cool, weird examples of odd things with times on dates and numbers and strings and other things, other code things that have come up in your research to talk about together?
Yeah. So if you just wait for the mic for the live stream.
Traditionally, New Year's Day was March the 25th, being 9 months before Christmas, of course. And that was moved as a part of the shift to the Gregorian calendar. But one of the things that didn't shift was that the additional day for religious purposes was February the 25th. So days February 25th to 28th, those religious festivals would actually occur a day later. So the day we add traditionally was the 25th, not the 29th.
Gosh, I don't know about that part, but I did know about March the 25th being Ladies' Day, so 9 months before Christmas. So in a simplistic world where it was a 9-month pregnancy, that's 9 months before Jesus' birth. And that's why we had New Year's Day then.
That's why the tax year was...
So the tax year, this is what I was coming on to. It's fantastically interesting around the tax year, and I'm still trying to get some more evidence for some of this. But the tax year was March 25th as a start, and then at the same time that we moved, the Calendar Act moved New Year's Day to January the 1st, and we moved in the same year from the Julian calendar to the Gregorian calendar by missing out half of September. Meanwhile, the tax collectors are saying, we don't want to change. We don't want to have a short tax year because that would make us look like we haven't been collecting as much tax, or other people would complain. So in order to have a whole year's worth, 365 days worth of tax, they moved it from March 25th to April the 5th, I think. This was in the 1800s. I'm possibly out by 100 years at this point. But on the turn of the century, 1900, or 1800 if I'm wrong, in the Julian calendar would still have been a leap year, and in the Gregorian calendar is not a leap year. And the tax office, I gather, and this is what I want to find more evidence of, said, do you know what? We're sticking with the Julian calendar, and that's why it's April the 6th instead of April the 5th. And since then they've gone, do you know what? Okay, enough's enough. We'll just stick with April the 6th forever, rather than getting gradually a day out. But yeah, it's fantastic stuff. If you ask what was the shortest year in the calendar, it is 17 whatever, 18 whatever, when we moved from March to January, because there was a year that was only 9 months long, and less than 9 months long because of shifting over September. It's fantastically weird and wonderful. And yeah, having things in ancient Syria or whatever, you then get into a whole different idea of how you measure time, because sometimes it can be relative. You say, well, I don't know the absolute date, but I know it was 3 years before this king came on the throne or whatever. Another interesting thing around dates and times and how we fail to understand situations, so almost serious again, I'm afraid. If you go to some developing countries where, or countries that have been particularly war-torn, and you try to put in IT systems for health. And so you ask for everyone's date of birth, and then when they're 3 years old, or even you give them a yearly checkup. And that's fine if everyone knows when they were born. Sometimes they don't even know which year they were born in, but quite possibly they only know the year. So, right, we'll simplify things. 1st of January 2002. And the next person, okay, oh, you were born in 2004. Right, 1st of January 2004. So you get huge populations that were supposedly all born on the 1st of January. and they all get a letter or an email or a phone text or whatever is saying, please come for your checkup 3 years later. And it's just, we haven't thought about the situation enough. We've tried to apply a solution that works in one context, in another, without understanding the people. And people are complex and they have real oddnesses. Not that they're odd, but they get in odd situations. Yeah, sorry, just making my point again.
Yeah, all horse races are born on the same day of the year.
All horse racing. Gosh, yeah.
I think it's January 1st.
January 1st, right. Or other questions? Okay, well, I hope I've given you something to think about and something to, this is not, for many talks, you can go away and say, I will play with that technology, and then decide, yes, I will use that in another project and learn more, or just go and say no. Empathy, thinking about people, is something that I hope you will take, and even if I move the needle just a tiny bit, I hope that will have an effect, and an effect way past software. So many of the problems in the world, I believe, are due to us not understanding each other well enough. Thank you.